Hi friends, welcome back in the series of neural network and deep learning. So today we will be doing some hands-on with MNIST dataset. So basically MNIST is nothing but it is a database, right? And the acronym stands for Modified National Institute of Standards and Technology. So basically the MNIST database contains handwritten digits 0 through 9 and can provide a baseline for testing image processing system, right? So we can say that the MNIST database is a large database of handwritten digit that is commonly used for training various image processing systems, right? So first thing, we import the library. So we need pandas, we need numpy, keras, and then keras.utils we import to categorical, then warnings to ignore all these warning, and then we import TensorFlow callback. So from this we import model checkpoints and reduce LR on Plateau. Right now we reading the data, we read the data set. So from keras.dataset we import the MNIST directly, then xtrain, ytrain, xtest, ytest we get it from MNIST.load data, and here you can see that downloading the data. So it has downloaded the required data. Now if we print the shape, so you can see the train shape, the test shape, and this is for y train and this is for y test. Right now y train of 0, so we have the 5 value in it. Now visualizing images from our data, so visualizing the first 10 images in the database and their labels. So matplot inline, import matplot pyplot as plt, defining the figure size, making a for loop I in range 10, plt dot subplot 1 to 10, right, I plus plus, then plt image show xtrain of I, right, cmap gray, and plt dot access is off, plt dot show. So these are the label for each of the above image. So 5 0 4 1 9 2 1 3 1 4. So this is how we got it from MNIST dataset. Now normalizing our train and test data, so flatten the images. So image vector size 28 by 28, xtrain dot reshape, xtrain dot shape of 0, then image vector size, similarly xtest dot reshape, so passing the shape at 0 and image vector size. Now normalizing input from 0 to 255 to 0 to 1. Now xtrain equal to xtrain by 255, similarly xtest equals to xtest by 255. Now training set, so we have this the training set and this is the test set. Now we are using one hot encoding on the target variable, of course dummy the data set. Now convert one hot vector using the two categorical function num classes 10, ytrain equals to categorical ytrain number of classes, then num classes, then ytest categorical equals to categorical ytest num classes. So print first 5 training labels as one hot encoded vectors ytrain, right, we are first 5 training labels as one hot encoded vectors. Now defining the sequential model, so here first importing the necessary libraries from keras like losses, optimizer, sequential, and dense, then image size of course 28 by 28, creating model of sequential, and now passing the parameters into the model dot add dense 256, activation ReLU, kernel initialization HE uniform, then input shape, image shape, right? So these are multiple dense unit with ReLU activation. Similarly with 64 ReLU, similarly with 32 ReLU, right? Now model dot add dense num classes activation softmax, for multi-class classification we use the softmax. Now compiling the model, so Adam equals to optimizer dot Adam, LR equals to 1E3, then model dot compile loss equals to losses dot categorical cross cross entropy, optimizer equals to Adam, matrices equals to accuracy, right? Now model dot summary, so here the summary of our base model is this. So these are the layer, dense 2, dense 3, dense 4, and the output shape we have of the each layer, then total parameter we have, the trainable parameter we got, and the non-trainable parameter we got here. Now putting the weight we got, so monitor equals to value accuracy, then save weights only true, mode max verbose 1, reduce LR, so reduce LR on plateau, so monitor validation loss factor 0.1, patience 2, minimum LR, we are passing all these things, then callbacks checkpoint reduce LR, right? Fitting the model, so of course history equals to model dot fit xtrain ytrain validation split, right? Epoch we are passing 10. Epoch means our model training will have 10 iterations, and in each iteration 128 it is the basically batch. In one batch 128 data points will be processed, and verbose is 2 callbacks, right? Now epoch 1, so here you can see that it is started by 1, now saving model to model weight dot h5. Similarly for 1 2 3 4, and finally we got this. Here you can see that in each iteration or each epoch we got the loss, right? And the best model is when the loss is decreasing, so here 3.34120805 so on so forth. The accuracy we got is 99%. Validation loss, again you can see that 0.8 validation accuracy that we got. Now predicting the model on test data, so y prediction equals to model dot predict x test. Now y prediction of 0, so here we got the values. Now input as our output are probability, so we will try to get the output class from these probability by getting the maximum values. So y prediction final, for I in y prediction final dot append np dot argmax I, right? Y prediction dot final 0, so here you can see that it predicted the 7. Now generating classification report, so sklearn matrix import classification report, printing classification report, y test y prediction final. So here you can see that the precision, recall, f1 score and support, of course the classification parameters. Now similarly applying the confusion matrix, so from sklearn.matrix info to confusion matrix, import seaborn as SNS, cm equals to confusion matrix, y test y prediction final, plt.figure, figure size we are passing, then we are making this heat map. So cm annotate true, fmtd, x label, y label we are passing as predicted and truth respectively, and finally we are drawing the heat map. So here you can see that these are the prediction, these are the truth, right? Now misclassified images, so index equals to 0, misclassified images we are making a list. Now for label predict in zip, so y test y prediction final, if label not equals to predict then misclassification will append the index, so index will increment by 1, print classified images, then print length of misclassified images. So here you can see that all we got it, the misclassified images and their total length. Now predicting the output, so image index 445, okay, plt image show, so this put as predicted values labeled and predicted probabilities, right? So if you see this, so was predicted 0, was labeled 0, predicted probabilities, here you can see that, and this is what it showed the img. Now accuracy curve, so loss accuracy equals to model dot evaluate, x test y test category, verbose equals to false, plt plot history dot history on of accuracy, history validation accuracy, then title we are passing model accuracy, y label x label, legend equals to training validation loss, right? And loc is best, now showing it. So here you can see that the model accuracy, these are the epoch 0 2 4 6 8, and these are the accuracy. So if we check for I mean if epochs are increasing, so our accuracy is also increasing, right? For training data set and validation data set, you can see that we and for validation data set you can see that with the yellow line. So yeah friend, this was all about the introductory video of neural network and deep learning on MNIST dataset. So I hope you got the slight idea about this, and our team will be making more content on this. But before that, please do like, share and subscribe, which will motivate us a lot to make more content for you guys. Till then, all the best. Thank you. Have a good time. Take care.